Good morning, students. Till now, in velocity and acceleration of mechanisms by analytical method, two classes are over in which we have just discussed about right from the beginning the basics of complex algebra, how to represent any link by means of vector, and after understanding how to write a link of any mechanism in a vector form using polar coordinates, we just discussed about the loop closure equation for 4-bar mechanism, slider crank mechanism, that is inline slider crank mechanism, and the offset slider crank mechanism. This is all discussed in first class. In last class, I have derived the velocity and acceleration of a inline slider crank mechanism, or simply slider crank mechanism, using complex algebra. Then I listed out the formulas based on which we have solved one problem. Today, continuing few more problems on slider crank mechanism. Before beginning, today I would like to list out the formulas which we have derived in the last class. First, inline slider crank mechanism. As you know that the base pivot point of the crank, that is point A, and the slider C, both will be in line with each other. Then it is called inline slider crank mechanism. For this, we have derived certain expressions. Before listing, as I said very clearly, that all anti-clockwise measurements should be taken as positive and clockwise measurements should be taken as negative. These are the sign conventions to be followed. So anti-clockwise is positive and anti-clockwise is negative. That is first point. Second is, what are the notations which we have considered in the derivation? Small a is the crank radius or the crank angle, and small b is the connecting rod length. Small d is the displacement of the slider or displacement of the piston. Theta 2 is the crank angle. If I differentiate theta 2 with respect to time, I will get angular velocity of the crank, that is omega 2. So omega 2 is angular velocity of the crank. Next, in the figure I can see theta 3. So theta 3 is the connecting rod angle. And as if I differentiate theta 3, I am going to get omega 3 with respect to time, that is angular velocity of connecting rod. If I differentiate omega 3 with respect to time, I am going to get alpha 3, which is the angular acceleration of the connecting rod. And if I differentiate omega 2 with respect to time, I will get alpha 2, that is the angular acceleration of the crank. Now in the problem, he says, in the statement of the problem, he says the crank is rotating at uniform speed or constant speed. It means alpha 2 is equal to 0 by default. So by default, alpha 2 is equal to 0. When we see in the statement of the problem, the crank is rotating uniform speed, at uniform speed or constant speed. If not, also one should assume alpha 2 is equal to 0, provided if alpha 2 is not given in the statement of the problem. So alpha 2, if it is given, you have to take whatever the value it is given. But if it is not given, by default you have to assume that, even though if it is not mentioned constant speed or uniform speed, you have to assume that the crank is rotating at uniform speed or crank is rotating at constant speed, thereby alpha 2 becomes 0. So these are the notations which we have used. First point, anti-clockwise is positive, clockwise is negative. Second, notations. After knowing all the notations, third point is, if alpha 2 value, what is alpha 2? Angular acceleration of crank. If it is given, you have to take the same value. If not, you have to assume by default alpha 2 is equal to 0. So these are the 2 points which you have to remember before the formulas. Now in the formulas, whichever the problem it may be on inline slider crank mechanism, you have to use these formulas. One is, first you have to find connecting rod angle theta 3. Theta 3 is equal to sine inverse of minus a by b into sine theta 2. A is crank length, b is connecting rod length, theta 2 is the crank angle. With that you can calculate theta 3, that is connecting rod angle. Next, find the angular velocity of the connecting rod. Angular velocity means omega. Angular acceleration means alpha, remember. So now the second thing is angular velocity of connecting rod. That is omega 3, which is equal to minus a omega 2 into cos theta 2 by b cos theta 3. Minus a omega 2 cos theta 2 by b cos theta 3. That gives the angular velocity of connecting rod. So a is again crank length, omega 2 is angular velocity of crank, theta 2 is the crank angle, b is connecting rod length, theta 3 is connecting rod angle, which we calculated using first formula. So with that you can get omega 3. Next, after finding crank angle and angular velocity of a connecting rod, then calculate velocity of the slider, that is V suffix C is the notation which I have used. It is not that you have to use the same thing. Just write it, velocity of slider, that is Vc is equal to a omega 2 into sine of theta 3 minus theta 2 by cos theta 3. So except velocity of slider, remaining all things are known on the right hand side of this equation. Therefore you can use this formula in order to find the velocity of the slider. Next, find the angular acceleration of connecting rod. Angular acceleration means alpha of connecting rod, means it is link 3 of a slider crank mechanism. Therefore alpha 3 is the angular acceleration of connecting rod, that is alpha 3, which can be found by using this expression, a omega 2 square into sine theta 2 plus b omega 3 square into sine theta 3 minus a cos theta 2 into alpha 2 whole divided by b cos theta 3. Using this you can find angular acceleration, that is alpha of which link 3. Therefore it is alpha 3. Next, find the acceleration of slider, that is linear acceleration of slider, AC, because slider is a sliding component which slides on the guideways. So in between the guideways, so acceleration of slider, that is A suffix C, is equal to A alpha 2 into sine of theta 3 minus theta 2 minus A omega 2 square into cos of theta 3 minus theta 2 minus b omega 3 square whole divided by cos theta 3. So here A is known, alpha 2 is known, theta 2, theta 3, omega 2, omega 3, everything is known. Just substitute and find the acceleration of slider. So these are the 5 formulas which you have to remember in order to solve the problem on slider crank mechanism, that is inline slider crank mechanism. First point, anti-clockwise is positive, clockwise is negative. Second, you have to remember small a is crank length, small b is connecting rod length, theta 2 is crank angle, omega 2 is the angular velocity of the crank, alpha 2 is the angular acceleration of the crank. Then theta 3 is connecting rod angle, omega 3 is angular velocity of crank connecting rod, and alpha 3 is the angular acceleration of the connecting rod. So after understanding this, so alpha 2 by default it should be assumed as 0 if it is not given in the problem. Now these are the 5 expressions which you have to mug up or you have to remember using small tips, right? So remember only 5 formulas. First, connecting rod angle. After, because theta 2 will be given, theta 3 you have to find, first point. Second point, you have to find the velocity of slider and connecting rod. So first, after finding theta 3, angular velocity of connecting rod. After finding angular velocity of connecting rod, then velocity of the slider. Next, you have to find the 2 accelerations. One is angular acceleration of connecting rod, then the acceleration of the slider. Like that, these are the 5 formulas which you have to remember in case of a slider crank mechanism. Though I have listed a offset slider crank mechanism, in the next class, by discussing about the offset inline slider crank mechanism, I am going to solve few more problems. Today, only the 4 problems I am going to solve that are important and as well as came in the previous question papers on inline slider crank mechanism or simply a slider crank mechanism. Now taking, this is the problem which is given in the model question paper, second one. In the last class we have solved one problem which is given in the first model question paper. This is second model question paper. So he has given only a statement like this: for a single slider mechanism shown, determine the velocity and acceleration of the piston, angular acceleration of connecting rod. Take crank length is equal to 50 mm, connecting rod is equal to 200 mm, and crank speed is equal to 300 rpm. In the bracket he has written constant, and crank angle is equal to 30 degree. So whether the figure is given or not, along with the formulas, you must be able to draw the figure of the slider crank mechanism by default. So along with the formulas, you must also practice of drawing the inline slider crank mechanism figure, right? So that will give you a clarity. So what is to be calculated and what are the formulas. So therefore, whether the figure is given or not given, so you must draw the figure which is given in the formula list. Along with the formula list, whatever the figure is given, that should be drawn. So now in this problem, what he has given, crank length is given. So according to our notation, it is small a, which is given as 50 mm. So 50 divided by 1000, if I make it, it will be 0.05 meters. Then connecting rod is equal to 200 mm. That is nothing but small b, which is 200 mm. That is 200 divided by 1000 is 0.2 meters. Next, crank speed is given 300 rpm, constant speed. So speed of the crank, that is N2. So here see the unit rpm, revolutions per minute, means it is N. If it is given in radians per second, then I would have taken directly this as omega 2. So here crank speed, that is N2 is equal to 300 rpm, and Crank angle is given, that is theta 2, which is equal to 30 degree. Now what actually is asking, determine the velocity and acceleration of piston. So velocity of the piston or velocity of the slider, one or the other same, that is Vc. Acceleration of piston or acceleration of slider means it is AC. Vc AC to be calculated. Then angular acceleration of connecting rod. Angular acceleration means alpha. So alpha 3. Connecting rod means link 3. So alpha 3 is to be calculated. So now with the given speed, before taking up the problem to find the given things in the to find. So first, as the speed is given, with that first I will calculate omega 2 because n2 is given. So angular velocity of the crank, that is omega 2. So in general omega, you know that it is 2 pi n by 60. Here n is nothing but n2. So 2 pi n2 by 60. 2 pi into n2 value is 300 divided by 60. If I simplify, it will be 31.416 radians per second. Now immediately after omega 2, he is saying crank is rotating at constant speed. Therefore, angular acceleration of crank, that is alpha 2, is by default 0. In the bracket I wrote it, since constant crank speed. Like that, omega 2, theta 2 must be ready along with small a and small b to solve the problem. Next, take the first formula, that is connecting rod angle, that is theta 3 is equal to sine inverse of minus a by b sine theta 2 from our formula list. A is 0.05, b is 0.2 and theta 2 is 30. If I substitute and simplify, it will be minus 7.2 degrees. But actually in the figure, if you see, theta 3 is measured in anti-clockwise. Therefore, to get theta 3, further what I should do, this given value should be subtracted from 360 degrees. Therefore, theta 3 is equal to 360 degree minus 7.2, which comes theta 3 as 352.8 degrees. So this is the value of theta 3. After connecting rod angle, then find velocities. First, which velocity? Angular velocity of connecting rod, that is omega 3. Use omega 3 formula, minus a omega 2 cos theta 2 by b cos theta 3, which in turn, you know all the values. A is known, omega 2 is known, theta 2 is known, b is known, theta 3. Substitute all the values and after simplifying, omega 3 is equal to here minus 7.854 units or radians per second because it is omega. So, but what this minus 7.854 indicates, omega 3 is 7.854 radians per second. Because of negative in the bracket I wrote, it is clockwise. This is the indication of that negative sign. Next, after finding angular velocity of connecting rod, then find velocity of slider, that is Vc, that is equal to a omega 2 into sine of theta 3 minus theta 2 by cos theta 3. Once again, here also everything is known. If I substitute and simplify, I am going to get minus 0.96 meters per second. This negative sign indicates that slider is moving towards the crank end with a velocity of 0.96 meters per second. So minus, if it is coming, means the velocity is towards the crank end. The velocity of the slider or the piston is towards the crank end. Suppose if it is plus, then it will be, you must write in the bracket, away from the crank end. Like that you can calculate first theta 3, then the two velocities, angular velocity of connecting rod and velocity of slider. So after that you go for the accelerations. So first, which acceleration? Angular acceleration of connecting rod, that is alpha 3. So you know the formula, you write it, alpha 3 is equal to what? Now in this formula, I can cancel one of the term in the numerator, that is alpha 2, because alpha 2 is equal to 0 in this problem. Its value is not given. And moreover, he is saying crank is rotating at a constant speed. Therefore, by default, alpha 2 is equal to. So, after cancelling the third term in the numerator, that is alpha 2 is 0, 0 into a cos 2, this whole term becomes 0. Thereby, alpha 3 is equal to a omega 2 square into sin theta 2 plus b omega 3 square into sin theta 3 by b cos theta 3. Now substitute all the values which are known in this formula. So if I substitute and simplify, I will get alpha 3 is equal to, it is a positive value, 116.56. Alpha 3 is angular acceleration. Linear acceleration means meter per second square is the unit. Now it is angular acceleration. Units are radians per second square. In the bracket, I'll write anti-clockwise because its value is positive. Suppose if it is negative, you must write clockwise. Next, find finally the acceleration of slider, that is AC. So once again, write down the formula. So A alpha 2 into sine of theta 3 minus theta 2 minus A omega 2 square into cos of theta 3 minus theta 2 minus B omega 3 square by cos theta 3. So in this, once again, first term in the numerator is going to become 0 because alpha 2 is equal to 0. If this becomes 0, then AC is equal to, in the numerator, only two terms. What are they? Minus A omega 2 square cos theta 3 minus theta 2 minus B omega 3 square whole divided by cos theta 3. So if I substitute all the values which I know, then I will get the value as minus 52.05. It is linear acceleration, therefore units are meter per second square. So like that, one can solve the problem on in-slider mechanism. So this completes the two problems on slider crank mechanism. So students, once again I am repeating, remember anti-clockwise is positive, clockwise is negative. Second, 5 formulas. First, theta 3. Second, omega 3. Third, VC, that is velocity of piston or slider. Fourth is acceleration, that is which acceleration? Angular acceleration of the crank, that is alpha 3. Then linear acceleration or simply acceleration of slider or piston, that is AC. And apart from this, you remember whether the figure is given or not given. If it is a slider crank mechanism, you try to draw the figure which is available in the formula list so that you can note down what are the given things according to your notations. What is small a, what is small b, what is theta 2, what is alpha 2. What are all the given things you can list out according to our notations if you are able to draw the figure even though it is not given in the question. Then take the next one. It is July 2019, appeared. In a reciprocating engine, the length of crank is 250 mm and the length of connecting rod is 1000 mm. The crank rotates at a uniform speed of 300 rpm clockwise. Crank is at 30 degree from inner dead center. Determine first velocity of piston and angular velocity of connecting rod. Second, acceleration of piston and angular acceleration of connecting rod by complex algebra method from first principle. Here in analytical method, as far as our syllabus of the module 3 is considered, only we are using a complex algebra method, even though other methods like trigonometry, using trigonometry and all, it is not there. So by default you have to go for the complex algebra method if it is mentioned or not mentioned, because our module 3 only using complex algebra, which is one of the analytical method to find the velocity and acceleration. Now if I draw once again, immediately draw the figure. So and note down, write down what is very small a, very small b, where is theta 2, where is theta 3, right, omega 2, this and all. You must draw the same figure which is in the formula list. Now if I look at what are the given things, crank is 250 mm, so that is nothing but crank length. in our figure, what is crank length? Small a. So small a is equal to 50 mm. Then if I divide with 1000, I am going to get in meters. Sorry, here still I have written mm, you make it as meter. So 0.25 meters it is, not millimeters, because I have divided millimeter by 1000. So I am going to get in meters. Next, the length of the connecting rod, that is small b, which is equal to 1000 mm. 1000 by 1000 is 1, so 1 meter. And next, the crank rotating at a uniform speed of 300 rpm clockwise. So therefore, N2, which is given as 300 rpm in the bracket, you should not forget clockwise. You must write whatever the direction is given. If it is not given, then you assume anti-clockwise. So here it is given clearly clockwise. And the other one is crank is at 30 degrees. So therefore theta 2 is equal to 30. So now with this, small a is given, that is 0.25 meters. And small b is given, it is 1 meter. And N2 is 300 rpm, but it is clockwise. And theta 2 is equal to 30. Now first find out omega 2, that is angular velocity of the crank, that is 2 pi N2 by 60. And here N2 I have substituted as minus 300 because it is clockwise. I told clockwise is negative, anti-clockwise is positive. If he has given clockwise, you must remember that you must substitute the value with a negative sign without forgetting. Therefore 2 pi into minus 300 by 60, it will be minus 31.416 radians per second. Next, angular acceleration of crank, that is alpha 2. Here in the statement, are you finding a word called constant speed or uniform? No. So what I told, so you have to assume that crank is rotating at uniform speed, thereby alpha 2 can be assumed as 0. So with this, now find out first theta 3, it is sine inverse of minus a by b into sine theta 2. If I substitute, I am going to get minus 7.2 degrees. Then further, you should not forget to subtract it from 360 degrees because theta 3 is measured in anti-clockwise. So therefore, so that theta 3 value will be 360 minus of 360 minus this theta 3, what I am going to get. So 360 minus 7.2, it is 352.8 degrees. So that is the connecting rod angle. Next, find the velocities. Two velocities. First, angular velocity of connecting rod omega 3. Use that formula, minus a omega 2 cos theta by b cos theta 3. Here a is 0.25, omega 2. Once again, it is minus 31.416. Cos theta 2 is cos 30 by b is 1 meter and cos theta 3, that is cos 352.8. If I just substitute and simplify, I am going to get value is equal to 6.85 and units are radians per second because it is angular velocity. Linear velocity meter per second. Angular velocity radians per second. Acceleration, that is linear acceleration, meter per second square. Angular acceleration, radians per second square. These are the units. So now after finding the angular velocity, here it is 6.85 radians per second, which is positive. Therefore, in the bracket, write down anti-clockwise. Next, after finding the angular velocity of the connecting rod, right, then find the angular velocity, then find the linear velocity of the slider or the piston, that is nothing but simply velocity of slider or velocity of the piston, that is VC, using the same formula, a omega 2 into sine of theta 3 minus theta 2 by cos theta 3. So here if I substitute all the values which I know, then I am going to get 4.78 meters per second. And this value of velocity is positive, it is plus 4.78. Therefore, so in the bracket, the crank is moving slider is moving away from the crank end because it is positive. If it is negative, towards the crank end. Next, find the accelerations. So in the accelerations, first one, angular acceleration of connecting rod. Angular acceleration of connecting rod. Angular acceleration of connecting rod, that is alpha 3 a omega 2 square into sine theta 2. Same formula you write down here. Once again, alpha 2 is equal to 0, therefore minus a cos theta 2 alpha 2 becomes 0, thereby alpha 3 is equal to a omega 2 square into sine theta 2 by theta 2 plus b omega 3 square into sine theta 3 by b cos theta 3. Now substitute, and the value of alpha 3 is minus 129.25, minus 129.25, and it is alpha 3 means angular acceleration, units are radians per second square, and it is negative. Therefore in the bracket you write down the alpha 3 value as 129.25 in the bracket clockwise. Next, after the angular acceleration, then acceleration of slider, that is AC. Once again, write down the formula, and in the formula, now the first term in the numerator becomes 0 as alpha 2 is 0, thereby substituting the A value, omega 2 value, theta 2, theta 3, B value, right, omega 3 value, all these known values which we know. In this formula, I am going to get acceleration is equal to 150.8, and units are meter per second square because it is linear acceleration. So like that, this problem can be solved. Next, problem number 4. This is appeared in June-July 2015. The crank and connecting rod of a reciprocating engine are 300 mm and 1500 mm in length respectively. So the crank and connecting rod of a reciprocating engine are 300 mm and 1500 mm in length respectively. The crank rotates at 180 rpm in the clockwise direction. Determine the velocity and acceleration of piston when the crank is 40 degrees from inner dead center. Also determine the position of the crank for zero acceleration of the piston. Use complex draw. So here you must draw first figure. After the figure is drawn, now if I read the statement, the crank and connecting rod are 300 mm and 1500 mm in length. Therefore, crank length is given. It is 300 mm, connecting rod length is 1500 mm. So according to our notations, crank length is small a, which is 300 mm divided by 1000 I should make, so that I will get velocity in meters per second and acceleration in meters per second square. So therefore I am converting given crank length and connecting rod length values in meters. So 300 mm by 1000, that will give 0.3 meters. Then crank connecting rod length is 1500 mm. So that is small b, which is 1500 mm divided by, if I do 1000, I will get 1.5 meters. Like that. So crank length and connecting rod length is given. Next, crank rotates at 180 rpm in the clockwise direction. So what is it? It is N2 is equal to 180 rpm in the bracket. Don't forget to write clockwise because it is rotating in clockwise. And next, determine the velocity and acceleration of piston. So you have to find VC and AC is equal to what? That is velocity of this piston or slider, velocity, then acceleration of the piston or slider. When the crank is 40 degree from IDC, 40 degree from inner dead center, that is nothing but theta 2 is equal to 40 degrees. Then also, apart from velocity and acceleration of piston, is asking determine the position of the crank. Position of the crank means theta 2. Again I should find theta 2 anyhow it is given. Again he is asking theta 2 value is equal to what? For zero acceleration. It means I should find once again in the second bit position of the crank, that is theta 2, for or if the acceleration is equal to 0. So there are two parts here. First, as usual, velocity and acceleration of the piston or slider is to be calculated with the known value of theta 2. Then in the second part, I should find again what should be the value of theta 2 if the acceleration is equal to 0. That is what the condition. Now first let us find angular velocity of the crank, omega 2. Sometimes the crank, you have to look at the unit of the speed. If it is radians per second, directly that itself is omega 2. Once again, you should not do it 2 pi n2 by 60. Here the speed of the crank which is given in revolutions per minute, therefore 2 pi n2 by 60 I should do it. So 2 pi into minus 180, because 180 rpm clockwise. According to our conventions, clockwise measurement is negative. So 2 pi into minus 180 by 60, it will be minus 18.85 radians per second. Then angular acceleration of crank, alpha 2. Here once again, if I read the statement, I am not finding any word called uniform speed or constant speed. So if so, even though, then I will assume by default, I have to assume by default a constant crank speed, therefore alpha 2 becomes 0. First find out as usual, because to know velocity and acceleration you must know the values of theta 2, theta 3, alpha 2, alpha 3. By default, whether he is asking or not asking, you have to start from the first formula, that is connecting rod angle theta 3 is equal to sine inverse of minus a by b into sine theta 2. Here a is known, b is known, theta 2 is known. Substitute, then I am going to get minus 7.4 degrees. Then further theta 3 is equal to 360 minus 7.4, then it will be 352.6 degrees. Then find angular velocity of the connecting rod, that is omega 3. So this is the formula. You note it down, write down from the formula list and substitute all the values. A is known, omega 2 is known, theta 2 is known, b is known, theta 3 is known. By substituting all the values and simplifying, I am going to get minus 2.9 radians per second. Therefore, omega 3, what is omega 3? It is angular velocity of the connecting rod is equal to 2.9 radians per second. I'll write only value, and in the bracket, because it is negative, I'll write it as clockwise. Next, after finding angular velocity of the connecting rod, velocity of the slider, that is Vc. Once again, you know the formula. So you write down the formula, that is a omega 2 into sine of theta 3 minus theta 2 by cos theta 3. Now here all values are known. Just substitute and simplify. I will get 4.19 meters per second. It is positive, therefore in the bracket you must write away from the crank end. If it is negative, towards the crank end. Next, after finding the velocity, then go for the acceleration. So angular acceleration of connecting rod, that is alpha 3. So once again, write down the formula and cancel one of the term which contains alpha 2, because alpha 2 is equal to 0. If I cancel the third term in the numerator, then alpha 3 is becoming only a omega 2 square into sine theta 2 plus b omega 3 square into sine theta 3 by b cos theta 3. Once again, theta 2, theta 3 is known, omega 2, omega 3 is known, a and b values are given. So substituting all the values, I am going to get 66.9, and it is alpha 3. Angular acceleration unit is radians per second square. As it is positive, in the bracket write down anti-clockwise. Then after that find the acceleration. So acceleration of slider, that is AC. So AC is equal to formula write down. Once again, here the first term in the numerator contains alpha 2. As it is 0, therefore this first term cancels. So therefore AC is equal to minus a omega 2 square into cos of theta 3 minus theta 2
minus b omega 3 square by cos theta 3. Then substituting all the values and simplifying, I am going to get acceleration, that is linear acceleration of slider AC is equal to 66.4 and units are meter per second square. Like that, now I got the first bit of the given problem. What is the first bit? You have to find velocity and acceleration of slider or piston. So VC and AC. In order to find VC and AC, I should find theta 3, omega 3, alpha 3. Then only I will get VC and AC. Then second part of the problem is position. Find the position of the crank, or the position of the crank is nothing but crank angle, that is theta 2, if the acceleration is 0. If the acceleration of the piston is 0, that is AC is equal to 0. Now take down the acceleration of the slider formula. I write down, here I have written the acceleration of the slider formula. Now NU alpha 2 is 0. Therefore, my acceleration formula is minus a omega 2 square into cos of theta 3 minus theta 2 minus b omega 3 square by cos theta 3. Now here what I should do, acceleration, because I should find theta 2 value. Don't substitute theta 2 value which is given in the problem. Here I should find theta 2 if the acceleration is 0. Therefore, I have put AC at 0. Then theta 2 as unknown. Remaining all values I have substituted. Except theta 2, remaining all values are known. What is it? Left hand side AC, that is equal to 0, because you have to find a theta 2, taking that acceleration is 0. Therefore, left hand side AC, that is 0. On the right hand side, except theta 2, remaining all values are known, that should be substituted. So now cross multiplying, then simplifying, I am going to get theta 2 is equal to 255.8 degrees. This is the crank angle if at all the acceleration of the slider is 0. If the slider acceleration of the slider to be 0, then the crank will be at an angle of 255.8 degrees. That is what the meaning of the problem. Then one more problem. It is appeared in 2013-14, December, January 2013-14. Now the problem number 5, it is December 2013-14, June in 2016 it came, 18 it came, 2019 it came. So now in slider crank mechanism, the crank radius is 100 mm. So and length of connecting rod is 500 mm. The crank is rotating in counterclockwise. Crank is rotating in counterclockwise direction at an angular velocity of 15 radians per second and the angular acceleration of 115 radians per second square. Find the acceleration of piston and the angular acceleration of connecting rod when the crank is at 60 degree from IDC. In slider crank mechanism means it is inline slider crank mechanism. Draw the figure. After the figure is drawn, read the statement and list out what are the given things. Now the crank radius, nothing but crank length, is 100 mm. Therefore, small a is 100 mm divided by 1000 gives 0.1 meter. Next, length of connecting rod is 500 mm. So that is small b is 500 mm, that is divided by 1000 gives 0.5 meters. The crank is rotating in counterclockwise, means anti-clockwise direction at an angular velocity of 15 radians per second. So directly here omega 2 is given, because if I look at units, you can understand it is angular velocity.
Here, even though he has given saying at an angular velocity means omega of, sometimes he will say at a speed of 15 radians per second, then also it is not n2, it is omega 2 only, because you have to look at the units. 15 radians per second counterclockwise means anti-clockwise. Therefore, directly I can write angular velocity of the crank, that is omega 2 is equal to 15 radians per second. So in the bracket anti-clockwise. Next, and the angular acceleration of 115 radians per second. So angular acceleration of the same crank. So that is alpha 2 is equal to 115 radians per second. So it is also clockwise. Then find the acceleration of piston, that is AC, and angular acceleration of connecting rod, that is alpha 3, when the crank is at 60 degree from inner dead center. IDC means inner dead center, 60 degrees. So crank angle, that is theta 2 is equal to 60 degrees. So after listing all this, here he has given omega 2 directly, and alpha 2 value is also given. If it is not given in all our previous 4-5 problems, we have taken it as 0. We have assumed it as 0. That is, so here alpha 2. So directly omega 2 is given. So therefore, instead of finding once again what we did in the previous problems, omega 2, because there the speed was given in, speed of the crank was given in revolutions per minute. Therefore, I calculated angular velocity. So, and alpha 2 is not 0 because here it is given. So directly I will go for our formula list. Connecting rod angle, that is theta 3, sine inverse of minus a by b into sine theta 2. A is 0.1, b is 0.5, and sine theta 2 is 60 degrees. So if I substitute all these values and simplify, I am going to get minus 9.97 degrees. It is approximately minus 10 degrees. Once again, theta 3 is equal to 360 minus 10 degrees. That will be 350 degrees, which is the connecting rod angle. After connecting rod angle, velocities. Go for the velocity. First, angular velocity of connecting rod, that is omega 3 minus a omega 2 cos theta 2 by b cos theta 3. Here a is known, omega 2 is known, theta 2 is known. In the denominator, b is known, theta 3 is also known. So substitute and simplify. I will get minus 1.523 radians per second, because it is omega. Unit is radians per second. So minus, therefore in the bracket I wrote it, omega 3 is equal to 1.523 radians per second clockwise, because it is negative. Next, after that, you find velocity of slider. So velocity of the slider. So velocity of the slider means, that is Vc, that is equal to a omega 2 into sine of theta 3 minus theta 2 by cos theta 3. So here also once again, except the velocity of the slider on the right hand side, you know all the values. A is 0.1, omega 2 is 15, sine of theta 3 is 350, theta 2 is 60 by cos 350. It will be minus 1.43 velocity. Therefore, it is linear velocity meters per second, because it is negative in the bracket towards the crank end. Slider is moving with a velocity of 1.43 meters per second. Then after finding the velocities, go for the accelerations. So angular acceleration connecting rod, that is alpha 3, which is equal to a omega 2 square into sine theta 2 plus b omega 3 square into sine theta 3 minus a cos theta 2 into alpha 2 by whole divided by b cos theta 3. Here alpha 2 term which contains will not going to cancel, because alpha 2 is not 0. Alpha 2 value is given in the problem. Therefore, so you have to substitute the given value. So after substituting all the values, I am going to get angular acceleration of the connecting rod alpha 3 as 27.485 radians per second square. It is positive. Therefore, in the bracket I wrote down as anti-clockwise. Then after finding angular acceleration of connecting rod, then calculate the linear acceleration of piston or simply acceleration of piston AC. Now AC is equal to, write down the formula. Once again here also there is alpha 2. Instead of cancelling the term, you have to consider and substitute the given value. So in doing so, substituting all the known values, I am going to get acceleration is equal to minus 19.96 meters per second square. So this is the way the last problem. So till now totally so have solved some 6 problems which are given in the textbook and as well as came in the previous question paper on inline slider crank mechanism. So in the next class I am going to solve the problems on offset slider crank mechanism by giving the list of formulas. So now no derivation in case of offset slider crank mechanism, and also easy to remember what is the difference in between slider inline and offset slider crank mechanism, and which formulas are common and which formula is different. So that I will make a list and I will explain and I will solve the problems on offset slider crank mechanism in the next class. Therefore, before concluding this, what I told today especially, because problems are directly substitution, put the formula, get the answer type, because I gave neatly the list of formulas. Second, anti-clockwise sign conventions. Anti-clockwise is positive, clockwise is negative, and figure should be practiced so that whether the figure is given or not given in the state along with the statement. If the figure is given or not given, you must remember the figure and you must remember the notations and you must remember the formulas and you must remember the sign conventions. Immediately before solving or attempting this problem, your mind should be in our page, formula page. Diagram, sign convention, formulas, everything. Okay? Thank you, one and all.